So this is the HCSR04. Okay, you might have seen it or might not have seen it. It's fine. If you can, just I think it's there in our lab. Anyways, there are 4 pins, right? You can see one is VCC, trigger, echo, and ground. Okay, so VCC and ground, they are used to power the device. Fine, and trigger and echo. So these are the 2 signal pins for this sensor. Okay, so do you have any idea how it works? Anybody? Any idea? Rough idea how it works? By the name of ultrasonic, something it has to do with ultrasonic waves, right? Any idea? You can unmute yourself, you can speak. We are only few people here. No idea? Okay, fine. See. Yeah, Minash, I think you are speaking. Go ahead. Yeah, high frequency, yes, correct. Swagata, yes, correct. See, how it works is, it will, transmit some ultrasonic waves, okay? Then, it will reflect back from surfaces, okay? Then it will detect those things, and based on that reflection and transmission, it will calculate the distance, okay? It's very easy, but let's just go into the details, okay? Actually bought a pen finally, because it's impossible to write with this mouse, Okay, see, this is how it will work. Okay, still I'm very bad at drawing anyways. Okay. How do I go back? Yeah. Okay, wait. Okay, so this is how it will work, okay? So obviously we need to connect it with some microcontroller, right? Because we need to send it some signal for it to work, okay? So first what we do is we send a 10 microsecond pulse, okay? From where we are sending it? From the microcontroller, okay? UC means microcontroller. Let's say Arduino, ESP, etc. Okay, so when we are sending this 10 microsecond pulse, okay, so the internal circuit, the internal circuit of HCSR04, let me mark it also, HCSR04, okay. So what it will do, it will, from the trigger pin, we'll just mark it as 3, and it will mark it as echo as E, okay. So after you have sent the 10 microsecond pulse, it will generate 8 pulses, 8, specifically 8. So you should ask me at this point, like, why specifically 8? Any idea? No. Okay, I'll tell you later. Fine. So these pulses are of frequency in the range of 40 kilohertz, okay? 40 kilohertz. My handwriting is very bad, so just bear with me. Anyways, see, so after this trigger pin pulse ends, the echo goes high, okay? The echo signal, it will go high, okay? It will go high. And when it will go low, see, I'll tell you. Let's say this is our sensor, okay? This is our sensor, fine. This is our ultrasonic sensor. And at this point, let's say it's transmitting something, okay? It's transmitting a wave, okay? This is some object in front of it, okay? So after hitting this object, these ultrasonic waves are very directional, okay? Directional means like this. Let's say here is some point, no? It's like this, directional, okay? So it goes on a certain direction, not like this, not like everywhere else, It goes on like this, not like this. Okay, so after these waves hit an object, obviously it will reflect back, okay? If the object is a bit smooth, okay, like a mirror or let's say some walls, okay, so it will reflect back, and it will be detected by the echo. Okay, so this sensor will detect it. Fine. So when at the point when it first detects this signal, this echo pin goes low. Okay, this goes low. Okay, and when it first transmits, then it goes high. So it goes high, high, high. So at the point when it receives, at the point where it receives the reflected wave, then it goes low. Fine. Now, do you know the speed of sound? Any idea? I'll just call it D, this duration. Okay, if you don't, I'll just quickly write it here. Maybe, yeah, speed of sound is around 343 meter per second. Fine. So our waves, these waves that is traveling here and coming back, they are at a speed of 343 meter per second. Right. And we want to calculate this distance. Okay. I'll just mark it as capital D. Right. This distance. This from the sensor to the object. So we have the speed. Okay. We have this time. Okay. So obviously we can calculate the distance, right? So are you getting what I'm saying? Give me a thumbs up quickly. I'll know if you are on the same page or not. Or should I repeat it once again? Avinash, Swagata, did you get it? What I'm saying? Or should I repeat it? Okay. Avinash, did you get it? It's okay, I'll repeat. Yeah, okay, cool. Fine. So I'll briefly repeat. See, this first we are sending a 10 microsecond pulse from the microcontroller, right? So when the sensor receives this 10 microsecond pulse, it will send 8 pulses, okay? I cannot draw 8 pulses, but I'm just writing it here. Okay, so it will transmit 8 pulses, okay? So why specifically 8? Because see, this reflection, right? So if it's too much, let's say if it was like 100 pulses, then there will be some mismatch in echo. The echo will receive some signals that are sent very early, okay? So the sweet spot is around 8 pulses, okay? If it was too small, then some pulses might be lost due to noise or something else, or maybe some rough surface, okay? So 8 is the number. Obviously, it can be 10 also, but ultrasound, this HCSR04, it uses 8 pulses. Fine. Okay, so this is sent. So at this point, when this, the last pulse, it gets sent, the echo pin, it goes high. Okay, the echo pin, it stays high for a certain amount of time. And when, at the point when, the reflected wave hits back the sensor detects the reflected wave, it goes low. Cool. Okay. So now let's say if we know this time, okay, if we know this time, the wave is coming here and coming back. If we know this time, we know the speed, we'll be able to calculate the distance, right? Yeah. Okay, so what will be the distance? Can you guys tell me? Speed into this time, right? This duration. Okay, let me mark it as T. Be more easier on the mind. Yeah. So it will be speed into time, right? Or am I missing something? Quickly tell me. Will it be T or something am I missing here? See, the time that we are, this time is the signal is hitting the surface and coming back. Get the idea? This time, that is, the signal is hitting the surface and is coming back. So, is there something missing here or is it correct? Will we get the distance? Yes, Avinash, you're correct. We have to divide the time by 2, right? Because see, we are counting the time twice, from here also and here also, but we need the distance only once, right? We don't want this distance. We don't want this round trip distance. Okay, we don't want this round trip distance. We just want this distance, just from here to here. We just want that. Okay, so it will be divided by 2. Fine. So that's how we'll calculate the distance. Cool. Now let's just code it. Okay. I think you guys have already have that ID installed. Okay, let me just quickly open one up. Okay, see, I don't think I need to describe these things to you because you're all familiar with this thing. Okay, we need to declare the trigger and echo pins, right? So let's just say trig pin to, let's say, 3 const int, my bad, mistyped, const int echo pin. See, at any point of time, if you don't understand anything while I'm typing, just ask me or raise your hand and I'll know. Okay, fine. Okay, we have described the trigger and the echo pins, right? Do we need something else? See, we are calculating the time at which the echo stays high, right? So we need to store it somewhere, right? We need to store that somewhere. So let's just call a float, let's say echo time, right? Echo time, okay? And what else do we need? We need to obviously calculate the distance. So let's say another variable we will keep, let's say distance, right? This will be the distance. Let me comment it. This will be the distance from the distance of the object from the sensor. Fine. Okay. Now we'll just go to void setup. Just make it large. Yeah. Okay, move this. Yeah, I can move this. Okay. So we'll go to the void setup. Okay. So now tell me, what is echo pin? Will it be an input pin or an output pin? Quickly just unmute yourself and tell me. Pin mode echo pin. Will it be an input pin or an output pin? Guys, any idea? So from the trigger we are sending something, right? And the echo is detecting something. So will it be an input or an output? Input, yes. Echo will be, yes Avinash, you are right. Echo will be input and this trigger will be output. Fine. Cool. Okay. So our voice setup is done because there is nothing else to do here. Okay. Where is this semicolon came from? Okay. Now we need to read the distance. Sorry, we need to calculate the distance, right? For that we need this duration of, what duration we need? This duration, this time. Okay, can you see my cursor or is it not visible? I don't know actually. Is it visible on Gmeet? Okay, cool. So we need this distance, right? We need this distance. Okay. So now how do we calculate this time? Okay, we need this time. We need the time when echo stays high, right? We need that time. So do you have any idea how do we calculate that? Obviously you don't have because it's a new concept. Okay. See, there is a function or let's say method. Okay, that method name is pulse in. Okay, pulse in camel casing. Okay, and echo pin high. I'll tell you what it does. So this pulse in, what it will do, it will calculate the amount of time this echo pin stays high. Simple, get it? Pulse in, it will calculate the amount of time that this echo pin remains high. Cool. Okay. Now what will you do? Now we need the distance, right? Distance will be what? Speed. What was the speed of sound? Okay, now see. Now the issue is, okay, let me just go back to the OneNote. See, now the issue is our sound, speed of sound was in meter per second, right? 343 meter per second. But this echo pin, okay, this echo pin, this thing, this duration, it is in microseconds. Okay, it is in microseconds. So we need to convert it. Okay, so if you convert this thing, 343, it will be around 0.0343 centimeter per microsecond. I know this because I have done this like thousands of times. Anyways, so we have just converted this to centimeter per microsecond because this whole thing, this whole figure is in microseconds. Okay, fine. Now let's just go back to this code. Okay. Okay, see, we are calculating the pulse in, we are calculating the amount of time the echo pin stays high, but we are forgetting something. We haven't sent the 10 microsecond pulse yet, right? So let's just first do that. Okay. So let's just send the 10 microsecond pulse. Okay. And how do you do that? Digital write, right? Digital write. Trick. Sorry, small letter. Trick pin high. Okay. And see, the thing is delay that you have used before, right? This function you have used before, right? So do you know what unit it takes? Delay, quickly tell me. You have used it before, guys. What's the unit of time that delay is in? Second, microsecond, millisecond, what?
Millisecond?
Yeah, correct. See, but we are currently working with what? Microsecond, right? So there is just a slight modification. Just put microseconds here. Okay, put microseconds here. And how much microsecond then we need to send? What was it? See, this thing. It was 10 microsecond, right? The sensor needs a 10 microsecond pulse. Okay, so we'll just, where is the sketch? Yeah. So we'll just send it a 10 microsecond pulse. Okay, so for 10 microsecond, this trigger pin will be high. Okay, now the issue is, see, this is the ideal situation, right? But the issue is, let's say before you are starting the values, the sensor might have some abrupt values like this, right? But we want to start from zero, right? We want to bring this to zero, right? Then we want to, make it high, right? So let's just first make it low for a very, small amount of time, let's say 3 microsecond or something, because we want to get rid of these things, these things. We don't want this thing. We don't want this thing. Okay, so let's just make it low first, then we'll set it high because there might be some noise or something. Okay, so digital write trig pin low, or let's say delay, my bad, delay microseconds, let's say 3 microseconds. Okay, you can put 1, 2, 3, anything, but yeah, just we want to make sure that it is low. Okay, before it is sending something. Okay, so now we have sent the pulse. Okay, we have sent the 10 microsecond pulse. Now the sensor itself from this internal circuitry, it will send 8 pulses of 40 kilohertz. Okay, now it will come back when it is, hitting a surface, and this echo time, it will store the value of the duration the echo pin stays high. Cool. Okay, now what will be the distance? Distance will be speed, right? What was the speed of sound? It was in microsecond per centimeter. Sorry, in centimeter per microsecond, it will be 0.0343, right? Multiplied by what? Multiplied by what? Tell me quickly. What? It's right, or you can unmute yourself. If you're confused, see this thing. See, this distance, this distance, this distance was equal to what? The speed, okay, the speed of sound multiplied by the duration of the time the echo stays high divided by 2, right? So what should I write in the code? Yes, yes, you are correct, T by 2. T by 2. And in our case, what is T? T is echo time, right? We have declared the variable echo time, right? So we'll just write echo time here. Got it? Echo time by 2. Fine. So we got the distance, right? So now we want to print it, obviously. Maybe you can print it. Have I declared serial monitor? Okay, no. Let's just declare that. Do you know what serial begin does? Can you guys quickly tell me if I haven't? Quickly. What does it do? Serial begin. Any idea? Okay, so the microcontroller, let's say you are using an Arduino, right? It is communicating with your, okay, cool. It is communicating with your laptop, right, or PC, whatever you are using, it is communicating through a protocol. Okay. In case of, see, I was using a ESP32C6. Okay. So it was using a UART protocol. Okay. UART, Universal Asynchronous something. Yeah. Universal UA Receiver Protocol, I think. Yeah, something like that. Let me check. I actually forgot the full form. But yeah, I have no shame. I can just Google it. What was the full form? Universal Asynchronous what? Receiver Transmitter. Yeah. Universal Asynchronous Receiver Transmitter, UART. Okay. So it communicates on that protocol. Okay. This thing. What is the code? Yeah. So it communicates through that protocol. Okay. So when we write serial begin, no, we enable the serial monitor. Okay, we can monitor whatever it is communicating. Fine. And when we write this, it can take many values, but 9600 is the most common used in Arduino, especially. This 9600 is it's the baud rate. Okay, 9600. Let me comment it. 9600 is the baud rate, that is bits per second. Okay, so if you use ESP, it will be something like 115200. So those number of bits per second. For Arduino, it is 9600. So these are some specific values. Here, okay, give me a thumbs up if you get it. The serial begin concept. Or do I need to repeat it? Got it? Yes, no, something. Okay, and rest of them, Swagata, Sugat. Yes, please repeat. Okay, see, whenever you are connecting a microcontroller, right, it needs to communicate with the device, right? The device as in your laptop or your PC. Okay, it will send the data, right? It will send the data or it will receive the data. So it does that through some protocols. Okay, protocol is nothing but think of it like as a language, language and grammar. Like now I am speaking at a certain speed, I'm using some grammar, I'm using some language, right? So for devices, for microcontrollers, for devices, they use some protocols to communicate with each other. Okay, you might heard about I2C, okay, SPI, those are also protocols. Okay, similarly, UART is also a protocol. Fine, but to display those values, those data that you are having, we use serial monitor, right? This serial monitor. Now it won't open because I haven't connected anything yet, but it uses some serial communication, right? So that to display that data, we have to start the serial communication. So that's what serial begin does. Okay, and the 9600 that I have written here, it is the speed at which that data transfer will take place. Okay, so it is the 9600 bits per second. Okay, did you get it, Sugar? Okay, cool. Good. See, if you don't get it, just ask me, okay? Because that way it will be more clear to you also. Okay. So right now I have initialized the serial communication. We have started the serial communication. Now we can just print the values, right? I'll just write serial dot print the distance is serial dot print. What is the distance? Distance is distance. Yeah, in centimeter, right? Just put centimeter also. ln means next line. Okay, ln means next line. Print means it will stay on the same line. If you put ln after the print word, it will go on the next line. Okay, centimeter. Fine. Okay. So when you will upload this code, and if you have connected the trigger and echo pin, you will get the distance. Is it clear? Is it like crystal clear how the sensor works and how we are calculating the distance? Clear? Give me a thumbs up quickly, then we will move on to some more concepts quickly. Clear how we calculated the distance? Yeah, Swagata, did you get it? Okay, cool. Fine. See, now, there are certain things called libraries right? So which makes our life easier, right? So while using this ultrasound sensors, there is a library called new ping. Okay, new ping, NEWPING. Okay, so what it does is basically does the calculation for us. Okay, right now we are calculating it manually, right? We have put like 0.0343 multiplied by this echo time, right? But when you are using this library, it will just do it, it's just a wrapper around this calculation. Okay, I'll quickly show you once it loads. Don't know why is it not loading. Yeah. Okay, wait, actually I've written this one, so maybe I can save some time and just show you there itself. Where is this new ping? I think this one. No, yeah. Okay. See, this sketch, simple sketch. So what we need to do first, just include the library. It's called newping.h. Fine. And similarly, we need two things, that is trigger pin and echo pin, right? And one more thing that we need, that is max distance. Okay, I think I forgot to tell you maybe. So this XR04, it has a max distance of 400 centimeters. Okay, like accurate distance. I'll just maybe write it here somewhere. Yeah. So it is a max distance of 400 centimeters and minimum distance of 2 centimeter. Fine. Okay. Plus, it's good to know. Okay, nothing else. Okay, but we need to, what is that? Yeah. So we've declared this max distance, right? It's 400. If you are using some different sensor, then it might be different. Okay. So looping. Now, do you remember servo? How we used to declare servo? Do you remember? Can you quickly tell me how you used to declare servo? You can type, you can speak, anything. Servo. First, what we did, we declared some library, right? Next, we created an object, right? We created an object. Do you remember servo? Give me a thumbs up or just write something if you can. I need a feedback so that I won't be repeating mundane things. Yeah. So we created an object. Yes, we created an object, right? So similarly here also, I just created an object. Okay. See, where is it? Yeah, this one. See, I just created. I'll for your reference. Okay. When we are using servo, it was like this, right? Servo. Let's say my servo, right? My servo, then servo pin, something like this, right? So here, same thing, but it takes three parameters. One is trick pin, echo pin, and the other is max distance. Okay, clear? That thing only. We're just creating an object called sonar. You can name it anything. It's conventionally everyone uses sonar, so I just put sonar here. Okay. Next, we need a variable to store the distance. Okay, serial that begin that you know already. Okay, see now how simple it is. Distance is equal to just write whatever the name you have given dot ping underscore centimeter. Okay, so this line will calculate the distance for you. Okay, you don't have to do all that 0.034t, but it's good to know. Now, why it's good to know? Because see, this this new ping, this distance, ping underscore centimeter, has a resolution of 1 centimeter. Okay, that means it can't put fractional values. Okay, it cannot put fractional values. So if you need more accuracy, you have to go the conventional way. Okay, so this is one way. Okay, now I'll go a bit deeper into new ping. Okay, see, at first we are doing what? If you remember, see, we're calculating this duration, right? We're calculating this duration, right? We're calculating this duration and then we calculate the distance, right? So we're calculating this duration using pulse in, right? So new ping also has something that can do that. Okay, I think I opened it already. Or maybe not. Is this one? Let's see this one. Okay, this is not late. Okay, anyways, I'll quickly write it. Okay. I can just directly go to it, right? Yeah. Yeah. Okay. I'll explain this part. Okay. See, when the sensor is taking measurements, right? Let's say this is taking some measurements. Okay. Let's say you have used some in a bot you have put this sensor on top maybe, and it is it is measuring the distance. Okay, it's measuring the distance from a wall or something. Okay. Now the first thing is what was it? Ping underscore centimeter. It has a resolution of 1 centimeter, right? So it cannot give fractional values. Okay, but if you want very accurate, if you want very accurate, then you have to do the traditional way. But here, instead of using pulse in, you will be using something else. Okay, and what is that something else? I'll tell you. See, uh, this distance that we are calculating, okay, these pulses that are going from here, and these are coming back here, okay. So let's say if this robot, or whatever platform you're using, that is a bit shaky as in, let's say it's moving a little bit, unwanted some movements are there, okay. Then what will happen if you measure it, if you measure the distance, right? You'll get some sort of noise. Okay, you'll get some sort of unwanted values. Okay, that will be, let's say, around plus minus, let's say, 1 centimeter. Okay, you're getting this error. Okay, you're getting plus minus 1 centimeter. Okay, okay. So let's say your platform or the robot that you're using, it shakes because of the motor driver or whatever reason. Okay, but we want some accurate measurements. Okay, so what will you do? We'll tell the sensor that send this ping signal 5 times, okay, or 6 times, or 7 times, okay. It will send 8 pulses, 8 pulses 5 times, 6 times, 7 times. Then it will, obviously they will come back and it will read those things, but the distance that it calculates, it will be the median, okay. Sorry, not the distance, the duration. The duration, the echo stays high, it will be the median of those values. Okay, I'll repeat because I have spoken very fast. I think you might not get it. This ultrasonic sensor, what it will do, to eliminate the noise, it will send one signal once, it will receive one, right? This is one iteration. Again, it will do the same thing. Okay, again, it will do the same thing. Fine. Again, it will do the same thing. Second time. And let's say we did it for 5 times. Okay, fine. So let's say when we are doing this, the first time it showed around, let's say, 5 centimeters, right? Let's say here it showed 4 centimeters, and so on. And here again it showed 5 centimeters. Okay, so now if you take the median of this median, it will be more accurate, right? Sorry, my pen. If you take the median of these values, then the noise is most likely to be eliminated. Okay, let's say at this point when you are taking the measurement, there some noise occurred. Okay, there's some sort of noise, or maybe the platform shakes a bit, so you get a different value, right? But if you take 5 values, this one, and some other values, and you get the median, let's say you get the median of around 5 centimeter, then it's more accurate, right? But while you are, in the earlier case, you might also get 4 centimeter, right? So that's the key difference. Fine. So I'll just quickly walk you through the code because I don't have much time. Okay. This one. Okay. Same thing. Same thing. First, what we did, we declared, included the library. Next, we defined the trigger and echo pins. Okay. We defined the max distance. We created an object, right? we declare two variables, that is duration and distance, right? This is the new thing, right? This is the new thing that we are doing. Number of iterations. You got what is iterations? Okay, I'll check if you are getting. Okay, are you guys getting it? Give me a thumbs up or just say it. I'll repeat, or do you want me to repeat? Do you find that? Do you understood the issue behind measuring it only once? Did you guys get it? Or am I going really fast? Should I repeat? Repeat the iteration part. Okay, cool. See. See. Yeah, okay. Fine. Sorry. Okay. See. What I'm saying is, iteration is nothing but very simple. Okay. First, okay, let's say this is the first time we are measuring. Okay. First time. Okay. Let's say we are measuring the first time. Okay. Okay. We calculate the distance. Not the distance, we calculate the duration. Duration. Echo stays what high. Okay, duration the echo stays high. Let's say this is 20 milliseconds. Okay, so okay, before going there, do you know why we are doing the duration? Do you know why we are calculating the duration the echo stays high? Can you unmute yourself and speak? That way I will know if you are on the same page or not. Why we are even calculating that duration? Why do you need that? Yes, no, quickly. Okay, I'll go again. Don't worry. Today we are going to digest this HCS0. See this thing, right? This diagram, this part. Okay, this time is what? This time is nothing but the signal going from this ultrasound sensor and hitting the object and coming back to the sensor. Okay, get it? Transmitting, then reflecting back and getting the signal back or detecting it, right? That is the time the echo stays high. Okay, so if we know this time that echo stays high and we know the speed of sound, then we'll be able to calculate the distance. Got it? Now see, in the first iteration, let's say the echo stayed high for 20 milliseconds, right? And when we are measuring the second time, from the same spot only, but due to some noise, or let's say the object is little bit shaky, or the measurement device is a bit shaky, right? So let's say we get a different value this time. Let's say we got like 25 milliseconds, right? And on the third time, let's say we got again 20 milliseconds, right? And on the fourth time, let's say we got some different value, let's say 24 milliseconds. Okay, see the values are changing, right? So if these values, this duration is changing, then what will happen? The distance will also change, right? The distance will also keep changing. It will go up, it will go down according to these echo values, right? The duration that the echo stays high. Did you get it? Now to solve this, okay, to solve this little problem, what we can do, we just can take the median. Do you know what is median? Like median is simple, right? Let's say 1, 1, 2, let's say 1, 2, 3, 4, 5. Okay, what is the median? This 3, right? So like these values, there will be some, you arrange them in ascending order or descending order, and then you pick the middle value. That is the median, right? Got it? Why we are doing this? To make it more accurate. Do you want me to repeat? Quickly tell me, did you get the idea? Okay. So Avinash, did you get it? See, you can ask me freely, okay? It's not like it's not a class or something. But I need to go in depth because there are certain things that it's really amazing to know. Because let's see, tomorrow, let's say you have some interview or something, you have some project, right? You did some project using this sensor, and the professor, just to test your knowledge, ask some very basic question. Okay. And imagine you are, going, just telling him how it works. Obviously, you will be impressed. That is also another point why you should always learn in that. Okay. It opens more opportunities. Then another thing is, if you are, making some project or anything, let's say you're going some competition or anything, okay, if you know how a sensor works, then you can implement it on many different levels. But if you just copy from a YouTube video or something, then you'll be, limited to that particular use case only. You won't be able to use the sensor anywhere else, right? So it's always good to know, from the scratch how it works. Okay, fine. So where was I? I think I was here, right? You got it? How we are calculating the median, why we are doing that. Okay. Now, where is it? Yeah. Okay. So this is the number of iterations we are going to measure it. Okay. Now in void setup, we have just put serial begin. Okay. This same thing only, I'm following it from here. After that, see, now the duration is we're taking the median. Okay, this thing is nothing but just what I explained. It will take just the median. Okay, how many times it will take depends on how many times we have put here. 5, we have put 5. Okay, so it will take the median of those 5 values. Okay, so after that it is just multiplying with the speed of sound. Okay, so see, this is a good coding practice. On the previous example, I think I didn't include this. See, I have told the maximum distance is around 400, right? So if it is showing more than that, then it is most likely the reading is inaccurate. Okay, if it is greater than 400 or it is less than 200, the reading is very likely to be inaccurate. Okay, and we don't want that. Okay, so I have just simply put out of range. Okay, we don't need that value out of range. Else, if it is under 400 and 2, we'll just printing the distance. Okay, I have just put some random delay. Okay, did you get it? Did you get the code? Or do you want me to repeat? Did you understood the code? Or do you want me to repeat? Quickly tell me in the chat. Sugat, Avinash, Swagata, should I repeat? The coding part, the code part. The rest is fine. Okay, sure. See, I'll start from the beginning, okay? Yeah, where's that? Being iteration. My PC is a bit laggy because because I'm recording. Okay, anyways, see. First thing the thing is how to calculate it without the library, right? That thing Okay, now what we're doing is we're calculating using a library. Okay, we're doing it using a library to improve our accuracy. That's the whole purpose of this thing. Okay, and how we're doing it? First step is always we have to bring the library, right? Like in case of servo, if you remember, we included what? Servo.h, right? Then we define this trigger and echo pin. Okay. So next we define that this is the max distance. Okay. Now next we created an object. Okay. So now you can name it anything. You can name your name also. You can name this new pin Swagata, trick pin, echo pin, max distance. That is also fine. Okay. You can name it anything. Okay. After that we have created the object, right? Now this object is ready. We need something, right? We need something to store the value of duration and distance. So this is the float part. Okay, it will be a floating number, right? The duration, it will be, it won't be 1 second, 2 seconds, it will be microseconds, right? So it will go in decimal places. So we have used float, right? Now this number of iteration part, this thing. Okay, so Gota, can you tell me, did you get this part? This thing, why we are taking multiple measurements? Did you get that part? Why we are taking multiple measurements, why are we iterating it? Because we want it to be more accurate, right? Okay, yeah. Okay, tell me, just unmute yourself and tell me why we are measuring the duration of echo pin, that is, how long it is high. right? Why we are measuring the duration of echo high? Why we are doing that? Quickly, anybody, quickly tell me. Because if you don't get that, then there is no point in continuing. I'll have to go back to it. Just quickly unmute yourself and speak. Or you can type. It's okay if you're.
To remove
Yeah. What?
to remove the noises and to
Yeah.
get the more accurate value.
Yeah. That is for the iterations. Okay. That is you're correct for the iteration. But tell me why we are measuring the echo duration. This thing. No mouse. Okay, wait. Why we are measuring this duration? Why this? Why this duration? Don't worry, I'll repeat if you don't know. Tell me. Idea? Any idea? Why we are measuring that? Or do you want me to repeat?
To get the distance,
Yeah. Yeah. Obviously, that's the point. We want to measure the distance, right? That's why we are doing that. Yeah. Okay. And how? I'll briefly I'll repeat. Okay. I think you have some doubts in that. That's why you are not getting it. Okay. For the time. Yeah. For the time. Yeah. But I think you have some little confusion there. So I'll quickly repeat it. Okay. I'll quickly repeat it. See. See. This was the echo pin. Okay. This was the echo pin. Okay. This was the trigger pin. Fine. And this is the pulse we are sending. I think you have no doubt in the pulse we are sending, right? This is just a 10 microsecond pulse, right? And after you have sent the 10 microsecond pulse, it will release 8 pulses, okay? 8. These are 8. The trigger, it will send 8 pulses. Fine. After it has sent 8 pulses, the echo will go high, okay? It will stay high as long as it doesn't detect the reflected signal, okay? The point at which it detects the reflected signal, it will go low. Fine. Okay, what does that mean? I'll tell you. See, here is our sensor. Here is our sensor. It is sending something. Okay. The point it starts sending this, the echo goes high. Okay. And I'll just draw the echo along the same line. See, this is the echo pin. Fine. This is the echo pin. The transmitter, no, it is transmitting the waves. Okay. It is transmitting the wave. At this point, the echo is high, high, high. Fine. Okay. Now it hit an object. Okay. It hit an object and it came back to the sensor. Okay. Now the sensor detected it. Okay. It detected that the wave is reflected back from an object. Okay. At the point when it detects that point, it goes low. Okay. So this time is what? The amount, the duration the echo stays high. What is it? It's the time the signal is going, hitting the object and coming back, right? This duration, this pulse, the length, sorry, the width, the time this echo, it is high, it is nothing but the time, the transmitted signal is hitting the object and it is coming back. Okay, is this point clear? Guys, is this point clear? Okay, it's lagging a bit. Anyways, is this point clear, guys? I can see the screen. Yeah, cool. Is this point is clear, right? So we got the time, right? We got the time. Fine, we got the time. We know the speed of sound. We know the speed of sound. So we can obviously calculate the distance now, right? So the speed of sound is what? 343 meter per second. Okay, but these all things are in microseconds. Fine. So we just change it to 0.0343 centimeter per microsecond. Fine. So distance will be this speed into this time divided by 2. Why 2? Because this is the time it's going and coming back, right? But we want this distance only. Okay, we don't want this whole round trip, we want only once. Like, what is this? Tell me that. Okay, that's why we're dividing by 2. Okay, so that is the reason why we're measuring this pulse. Okay, why we're measuring this, the duration, this duration. Why we're measuring this? Because we want to know the time. Fine, get it. Now, where were we? Here. Okay, now we are doing it 5 times to increase the accuracy. Fine. Okay, so see here, we have measured this duration how many times? 5 times, because I have put iterations 5. Okay, similarly, just we have calculated the distance, right? This part is clear. And this is just a simple if condition. Okay, if you don't know, this means or. Okay, these double lines. Okay, this means or. Okay, so if the distance is greater than 400 or the distance is less than 2, then it is in out of range, because the sensor, it cannot measure distances greater than 400 or less than 2 centimeter, 400 centimeter or less than 2 centimeter. Okay, so we're just printing out of range. Okay, else if it is within the range, then we're just printing the distance. Now is it clear, guys? Got it? Give me a thumbs up. Saugata, did you get it? Okay, cool. Avinash? Avinash, did you get it? Yes, centimeter, yes. Okay, let me check what you're writing. So if we take the echo pin high, we should not have to divide the time by 2. No, we have to divide it by 2. See, the echo only goes low when it gets the reflected signal. Get it, Sugar? When it gets the reflected signal, right? So it's a round trip. It's a round trip, but we don't want the distance of the round trip. Okay, did you get it, Sugar? Clear?
Yes.
Okay, cool. Fine. Okay. So I think this code is clear. This code is clear. Okay, now I'll go to uh okay, cool. Now see, in Micromouse, okay, if you build a simple Micromouse, how it will work, I need to give you some concept, then I'll give you an assignment. See, this, I'm really sorry for my bad drawing, but okay. See, this will be your bot. Okay, this is the body of the bot. Okay, there will be some wheels here. Okay, let's just say this is the wheel. Okay, I'm drawing the top view. Okay, top view, top. Okay, here you will have one sensor. Fine, you will have one ultrasonic sensor. Here we will have another ultrasonic sensor. Here, sorry. Here we will have another ultrasonic sensor. Okay, this point is clear. These are just wheels. Okay, maybe I shouldn't have drawn those, but yeah, it's fine. These are just wheels. Okay, fine. So these are ultrasonic sensors, right? Now the thing is in Micromouse. Okay, so it will be something like this. Okay, let's say this is the whole maze area. Okay, so there will be like walls here and here, like this maze type of a thing. Okay, like this. Okay, and your bot, your bot will be somewhere here. Okay, your bot is somewhere here. Let's just imagine that. Okay, so our bot is here. We have a front wall in front of us. Okay, so we have a wall in front of us. Okay, and we have a wall in the left of us. Okay, we have a wall. This is a wall. This is also a wall. Okay, we have a wall in front of us. We have a wall in the left of us. Okay, but we're clear on the right. Okay, we're clear on the right. This side is clear. Fine. So, what we need to do? Tell me, do we need to turn right or left? Just unmute yourself, because I don't want to just go to mute. Just tell me. We need to move right, right? How will we do
Yes.
it? Yeah. How will we do it? See, first we'll calculate this distance. Okay, not like it's not sequential, we'll do it at the same time. Then we are also calculating this distance. We are also calculating this distance. Right? So what will we see here at this point when our bot is here? This is our bot. Okay, this is our bot. Let's make him smile. Yeah, this is our bot. Okay, so it sees a wall in front of it. Let's say let's say it's 5 centimeter. Okay, the object is in 5 centimeter. Okay, here is also 5 centimeter. Okay, and we have written some statements in our code that if if this front sensor, I'll call this sensor 1 S1. Okay, I'll call this S2. Okay, I'll call this S3. In our code, we'll write something like this. Okay, just go down. In our code, we'll write something like this. If S1, S1 is less than or equals to 5, then what will happen? We see there is a front wall. Okay, and S2 is also less than equals to 5. Okay, then what will you do? We will turn right. Got it? Did you get this concept? Quickly tell me. Yeah. Now see, it's not that easy because this is just one scenario, right? This is just one scenario I'm describing here, right? What else could be the scenario? Let's say these are the 3 walls here. This is a wall. I'll just write that. Oh, sorry. How do I delete it? Yeah. So I'll just write W for wall, okay? W, wall, okay? Our bot is here now. Our bot is here now. We have 3 sensors, we have 3 eyes in 3 directions, and all of them are saying you cannot move anywhere, right? Then what we need to do? We need to go back, right? This is one scenario, right? What else could be the scenario? Let's say we have walls on both the sides. Wall, wall. Okay, our bot is here. Our bot is here. Then what we need to do? We have detected that I have wall here, I have wall here. So I'll go where? I'll just go ahead, move forward. Okay. So that's how it's, you have to code it. And I'll give you another scenario. Let's say our bot is here. Okay, our bot, our happy bot. Our bot is here. Okay. And we have a wall here. And maybe, a wall here. Okay, my mouse is stuck. Okay. Wall here. Something like this. Okay. Now, this is not the exact representation, but I'm just giving you the logic. Now, you also need to put something in your code like this. Let's say if, if, I'll just call it S1, S2, S3. Okay, I'll just calling it D3 distance. Okay, this distance, I mean, this D3. Okay, this I'm calling it as D2. Fine. This I'm calling as D1. Okay, so you also need to take care of this scenario, right? You have to say, put something in your code like if D3 is, greater than D2, then you move towards right or not turn right. Maybe you move slowly towards right, move slowly right. I'll just give you an example. Okay. Did you get the idea? Did you get some rough idea how a Micromouse works? It's much more than that, but did you get the brief overview? Quickly tell me. Okay, Swagata, Sugat, did you get it? How using 3 sensors we can navigate through a maze? Do you want me to repeat? Or did you get it? Sorry. Not the last one. Which part can you can unmute yourself. Just talk to me.
The last
Example, okay, the last example, fine. Yeah, that is really badly drawn, okay. Fine, okay. See, this is the scenario I'm talking. This is a wall, okay. This is a wall here, wall. These are the scenarios that I made up, but this will obviously occur. Okay. this. These are all walls, okay? These are all walls. Okay, this is the path, okay? This is the path. Fine. Now let's say our bot is here. Okay, that's what I meant actually. I'm sorry for the bad drawing. Okay, our bot is here. Do you want it to turn right or do you want it to turn left? Tell me. Unmute yourself. Sugar.
Turn right.
Turn right. Right. How will you do it? See, we will measure this distance. Right. We will measure this distance. Let's say D1. We will measure this distance. Right. Let's say D2. And what do you see here? D2 is greater than D1, right? Right. So, something like this scenario will come up. Okay, then you need to do what? Turn right. Get it? Yeah, these are the scenarios, okay? There will be many more scenarios. I think 12, I think, yeah, something like that. But maybe more than that. Did you get it?
Yes.
Yeah, fine. Okay, so that's how, a maze will be solved somehow. We'll cover some maze solving algorithms later, but for your project, okay, tell me, do you remember uh, how to use these things? Okay, everything. Actually, I couldn't take these sessions because I had some issues with my laptop and some work issues also. Okay, I think we have it here. Do you remember in the first session I covered something motor driver? Do you remember? Do you remember this thing?
Yes. Yes.
Vinash, do you remember? Swagata, do you remember this thing? I won't be repeating this, okay? It's impossible for me to repeat this now. If you don't, you'll have to just go through something. Do you remember? So what it does? It controls two motors, right? It controls two motors, right? I'll briefly tell you. Okay, it controls two motors based on these inputs. Okay, based on these inputs. Right. So let's say, it controls the two motors that fine. So let's say you are using that only. So how will your code look like? Your code will look like something like this, right? If let's say if front is blocked, that means front this. Okay, I'll have to draw the diagram, otherwise you won't understand. Uh, Mouse. Okay, let's say it's something like this. Okay, our bot is here. Okay, our smiley bot is here. Okay, this is our bot. We have three sensors, ultrasonic sensors. Okay, and we need to go right. Okay, we need to go right. Fine. So how will you code it? I'll just give you the logic. Okay, I won't tell you the code. How will you code it? It will go something like this, right? If this distance, let's say call this D1, this D2, this D3. Okay, so if D2 is greater than D1, okay, then what will you do? We will turn right. At this point, I am just telling you turn right. But if you are using, that moto driver, what will you write? You will write something like this, right? Digital. Okay, I'll just use short form. You will just write digital right. Okay, there will be some pins, right? Right, some input pin that you will, describe. So that pin high, and since you are turning right, you have to turn off one pin. Pin low. Got the idea? Got the idea how it moves through image? Guys, tell me quickly. Yeah. Yeah. So if you don't remember, how a motor is controlled using the driver, just quickly refresh that. Okay, then you'll be able to relate. Fine. Now see, I won't give you the whole, massive task of making a full code for Micromouse. Okay, but just do it for three scenarios. Okay, three scenarios. Okay, just do this thing. Scenario one. Okay, uh, scenario one. Okay, this is uh, our front part is blocked. Okay, your bot is here. You don't have to make a hardware circuit now, not yet. I'll ask Gautam if he can arrange something later, but not now. Okay, our bot is here. Okay, front wall is blocked. Front wall is blocked. Then you, okay, right, front block. Okay, just then turn left or right. Any one you want. This is called right following or left following logic. Just you can choose either one. Turn right. Okay, this is the scenario one. Second scenario two is, let's say your bot is here, smiley bot. Okay, so you need to turn again, turn right. Fine. Just right, put this arrow here. And the last scenario I'm giving you this way. Okay, right and front blocked, turn left. Okay, now see, how do you turn left and right? Do you know? If you have two motors, tell me quickly. See, these are not ears, these are wheels. Okay, these are wheels. Okay, these are wheels. Assume them they are wheels. Okay, you will have your motor driver here somewhere, right? This is your motor driver, right? You will have some pins here, something like, yeah. How will you turn right? How will you turn right? You will move this motor and stop this, right? Correct? Yeah. Someone was saying something. Just tell me, yeah. Tell me, how will you turn left? Tell me quickly. How will you turn left?
The left one, the left
Yeah.
one will be high and the right one will be low.
Yeah. I think you get the idea, right? And if you have to go back, then just both, rotate both of the motors in backwards direction, right? This direction. Fine. Okay. Now, uh, do one thing. Do one thing. Yeah. Okay. Sorry if you're typing, I didn't see you. Okay. It's okay. Do one thing in Tinkercad, right? In Tinkercad. If you can, I'm not, uh, because I don't know. I haven't tried it in Tinkercad, so I really don't know if it will work or not. Okay. Okay. In Tinkercad, just grab three sensors. Okay. You have this. Okay. What else do you need? You need three of them, right? Let me use my mouse quickly. Can I copy this thing? Is it copyable? I don't know. Fine. Okay, you will need three sensors, right? Okay, this is a three-pin sensor. This is also the same thing only, but just stick to what we have learned for today. Okay. Okay. So consider this as, left, front, and right. Okay. You plug it to an Arduino. I won't be plugging it because it's 9:30 already. You plug these things into Arduino. Okay. Maybe you need an one breadboard also. Fine. And you will have this motor, right? Sorry, motor driver, right? Then you will have this motor. Now, based on these inputs, if you simulate it, you will know there will be some, some blob and distance that you will be able to manually control. Okay, don't worry about that. If you are worrying that how will I put an object, okay, Tinkercad takes care of that. It will show something. Okay, if I haven't written any code. Okay, see, if I click on that, see this, you can change the distance. Okay, fine. So this is your left, right, and front sensor. Okay, now these scenarios that I these things. Okay, these things. Okay, if your front is blocked. Okay, if your font is blocked, that means just click here. If your font is blocked, just click here, bring it closer. That will mean it is blocked. Okay, then you move right. How will you move right? You will tell the motor driver, there's please turn on this motor and turn this off. Did you get the idea? Did you get the idea, everyone? Yes, good. But the thing is, yeah, try to do it. Okay, I think you can in 2 days. Yeah, 2 days is more than enough. Do one thing after you have done it. Give me your yeah, give me in Tinkercad, or maybe you can DM me also, and either way is fine. And just make a LinkedIn post also. Okay, because this is a very good concept that you have learned today. Okay, it will help other students also. You can mention me, so my people also will get to know. Okay, my people as in my followers and everything, they will also know that you are doing something amazing. Okay, just try to do it and make a LinkedIn post. Okay, and maybe create a GitHub profile. Okay, create a GitHub profile, and there what you have done, just upload it there. Okay, and if you make it a good habit, then you will have an amazing portfolio. Okay, cool. So the things you need to do is, are you clear? Give me a thumbs up. First, just implement these three scenarios in Tinkercad. Okay, then make a GitHub profile and just store it somewhere. The coding part. Okay, you can also attach images of the circuit. Okay, clear? It's for your own good only. Yeah. Please repeat again. Okay, sure, Avinash. Sure. See, Avinash, did you get the scenarios that I'm talking about? Front is blocked, right is blocked, left is blocked. These things you get, right? These three things. Okay. Now, based on these three inputs, okay, based on these three sensors, this is, let's say, front, right, and left. Based on these three sensors, you turn these motors. Okay, let's say this is your left motor, this is your right motors. Okay, and you want to turn right, then you will move the left motor, right? You will stop this motor and you will move this left motor. Okay, and how will you do it? Using this chip, right? This L293D. Okay, you need to just put input 1 as high, input 2 as low, and something like that. You have done one project while controlling this these motors, right? So my user have to integrate that thing, controlling the motors on the basis of the distance from the ultrasonic sensors. Cool, got it? Or do you want me to repeat? Avinash, did you get it? What I'm saying? Cool. Okay, amazing. Okay, so did you guys get something from this session? Understood something? At least 80%, 90%, 0%? Give me a number or just type it. Yeah, amazing. That's what matters, learning something. Okay. Uh, the thing is, you need to actually, that see, if you learn something and you don't do it, after 5 days you'll forget it. Okay, so the best time is to do it now, of course. Now, okay, just try to do it now. If you can't now, maybe you have some dinner or something, that is fine, but try to do it by tomorrow. Okay, try to do it by tomorrow. That way you will retain everything. Okay, learning is the first step. Retention, you will have to also retain those things that you have learned. Okay, I'll try to give you the notes. Okay, but yeah, my handwriting, I don't know how much useful it will be. But anyways, fine. Do you guys have any questions for me or anything that you want to ask? Anything related to your career, your anything, mentor, anything? No? Yes? No? Give me something. Yeah. Do you have any questions? Quickly tell me. We're almost more than 1 hour, right? Yeah. No questions. Okay. Cool. So, yes, sure. You can send me. Okay, sure. Do one thing. Do it Monday. You can submit, right? Monday you can submit, and I will have more of these sessions. But the thing is, it's very difficult to schedule some time. So I'll have another session. Okay. Your assignment, not assignment. Don't take it as assignment. Take it as self-learning. Okay. Just do those three scenarios and try to find out about IR sensors. Okay. That thing is very easy. Okay. That depth that we have covered this sensor, that is nothing. Okay. In front of this. That is very easy. Okay. Just try to see how it works. Okay. Yeah. Sure. I'll ask Pranjit. Okay. Yeah, he's actually very busy right now, but yeah, I'll ask him. See, this whole bootcamp, okay, it's not like we're ending it in 2 months, 3 months, or something like that. We'll only end it when we have completed the projects, okay. And you guys are the pilot batch, okay. I think you three guys and only two more guys are attending, five of you guys. But we are pretty sure when you end this session, you will have at least like a solid knowledge, okay, from which you can build upon new things. Yeah, I'll ask Ranjit, okay? Don't worry. Okay. If you don't have any questions, yeah, which one is better? IR, it depends on the use case. Avinash, it depends on the use case. The IR sensors, the normal IR sensors, let me quickly show you. This is the IR sensor. Uh, IR sensor. These things, right? So, these things, they cannot, measure the distance. Okay, they cannot measure the distance. Why? Because they are not directional. Okay, the ultrasound, they are very directional. The waves it transmits from the ultrasound, they are very directional, but IR is not directional. Okay, so it cannot calculate the distance, but it can calculate if there is something or not. Okay, it can detect an object. Okay, and it can detect black and white surfaces also. Okay, because white surfaces, they will what? They will reflect, but black surfaces, they won't reflect. So it depends on the use case you are using Avinash. Okay, am I clear? Yes, Sugat, you are right. Because see, the line is what? Black, right? So if you put some logic behind it, let's say you are coding it like this, that if you see, if you detect, if you detect some black value, just move your motor forward. Okay, that's why we use IR sensors in line followers, because it can detect black and white. Why? Why it can detect? Because black doesn't reflect back, but white reflects back. Okay, the light. I mean, yeah. Okay. Any more questions? I won't be covering IR because it's very simple. That's for you to figure out. Any questions? Any more questions, guys? No. Sugat, no. Avinash, no. Sogata, do you have any question? No. Okay, fine then. Okay, we are ending this meet. I hope you have learned something interesting and amazing. Okay. Yeah. Have a good night. Bye, guys. I'll see you in the next session. Okay. Bye.